Okay, in this video I will explain how to find the moment of inertia of an area depending if we use vertical or horizontal stripes and if we want to find Ix or Iy. So let's use Ix first, and in this example I will use horizontal stripes and this one a vertical stripe. Let's begin by the horizontal stripes, okay? And this is the centroid of the little element dA. This element dA, so that's x and that's dy. So the little element of area is a equal x dy. Now what we want is the Ix. Okay, so we are looking to find Ix. So your Ix will be equal to the Ix at C of the little element dA plus d square, that is this distance d, that is equal to y times the little element dA. So let's put d on each of them. Oops. And dA. So we have d for the Ix, that is equal to dic. That's 1/12 of the bh cube, right? Let me write it in this direction. So I at C is equal to 1/12 of bh cube. Okay, so if it's horizontal, that's your b and that's your h. If it's vertical on this side, I C would be equal to 1/12 of hb cube. Okay, so this is the I write it in the other direction, and now I'm at the h, and that's your b. Okay, so let's come back on our horizontal stripe. So this hb cube, 1/12 of hb cube is 1/12 of bh cube, sorry. So b, that's my distance x, and my h cube is my dy cube, plus the d square is the y square, and the dA is equal to x dy. Now the dy is very small. It's just a little stripe. Okay, so dy cube is even smaller and smaller. So we can assume that this is 0. So at the end, what we have is dix. It's equal to y square x dy. So we can write that Ix is equal to the integral of the y square x dy. In the case of using an horizontal stripe. Now, for this one, that will be a little bit longer. We have the centroid C, okay, and dA. What is equal to dA? So this is y, and this is dx. So dA is equal to y dx. Okay? Makes sense, opposite directions. Now, dx is equal to, that's my Ixc. That's my, yeah, that's my moment of inertia about C. So it's equal to dic to the centroid plus the distance d, that is equal to what? That's not equal to y, that's equal to y divided by 2. Okay, make it a little bit bigger. Just want to speak about this one. So plus the d square dA. Let's write more like dix. It's equal to. Now this one, that's what we wrote there. 1/12 of hb cube. Okay, so it's equal to 1/12 of the h. I should write. If I put b like this, it's still bh cube. Sorry. Okay. If I tilt it, it's hb cube. So 1/12 of b dx times h. What is h? Is y cube plus d square. D square, d is y divided by 2. So y divided by 2 square, and the dA I find there is y dx. And now, in this case, we don't multiply dx by, we don't take the cube of dx, we take the cube of y cube. So we cannot assume that is 0. So dix is equal to 112 of 112 times y cube dx, plus this is 1/4 of y cube dx. So dix is equal to 112 plus 1/4. It's equal to 112 plus 312. It's equal to 412. Okay, so it's equal to 112 plus 1/4. You multiply it by 3. You multiply by 3. Y cube dx. So dix it's equal to 4 divided by 12. Let's make 1 divided by 3. Y cube dx. So at the end we have ix that is equal to the integral of 1/3 of y cube dx. So if you take a vertical stripe to find ix, you need to use 1/3 of y cube dx. Okay, and it's not true for all the cases. It's true when your vertical stripes is going from y to 0. Okay, so just be careful, don't use it all the time. This is ix, this is ix. Okay, so yes, let me do it with iy. So we did the horizontal stripes, so let's do the horizontal stripes on this side. Horizontal stripes and vertical stripe. That's easier with the y, with the vertical stripe with y. So let's do this one first. So that's the C. So now dA, so this is dx, and this is y. So dA is equal to y dx. Okay, and what we are looking for is ix, and we will use the iyc. So we are iy, sorry, is equal to the iy at the centroid plus the d square dA, and the d is this distance between the y and yc. So d is equal to x. So iy is equal to, so the iyc, so you need to rotate 90 degrees and look at your 112 bh cube. So this is b is a y, and this is h, that is dx cube, plus the d square is x square, and the dA is y dx. Dx is cube, so this one is very close to 0. So it's neglectable. So we have at the end, oh, and that's d. Oops. And so diy is equal to x squared y dx. So when you take the integral of all the little y, we have y that is equal to the integral of x cubed y dx. Oh, x squared. Why did I get a cube there? X squared. Yeah, should be units at the fourth, meters at the fourth. So that's the formula if we use vertical stripes to find iy. And now if we try to find iy with horizontal stripes. Okay, so dA, in this case, this is x, this is a little dy. So dA is equal to, we put there, dA is equal to x dy. Okay. And I will use the y at C, at the center at C. And what I'm looking for is the I at Y. So I have di at Y, that is equal to the di at the centroid plus the distance square times dA. And the distance is this one. This is d, and d it's equal to, this is x, so this is x divided by 2. So diy it's equal to, so the dic. So you rotate 90 degrees and it's equal to 112 of b. So B is your dy. H cube is your x cube. Plus the d square. D is equal to x divided by 2. Square, and your dA is equal to x dy. Okay, so diy it's equal to 112 plus 1/4 of x squared times x is x cubed, so x cubed dy. I factorize everything. So diy it's equal to 1 divided by 3 x cubed dy. 112 plus 1/4 equal 112 plus 312, it's equal to 412, it's equal to 1/3. So if you take the integral on both sides, we find that iy is equal to the integral of 1/3 x cubed dy. Okay, so that was to find iy using a vertical stripes or an horizontal stripes, and again, that's the same type of area that is close to the y-axis and the x-axis. It could be different with other type of area. So this is the table. I will put these pictures on your website too. Okay, but that's the explanation of why we don't use the same integral if we use vertical or horizontal stripes if we want to find ix or iy. Our recommendation, if you can, use horizontal stripe for ix and vertical stripe for iy. Remember, the y is vertical, the x is horizontal. That's the way I remember it. So that's it for this little explanations. I see you in another video. Bye bye.